Part of the art form here is thinking while you're making things. It's like sketching. You're drawing and thinking at the same time. And that's a powerful connection to make. Thinking with my hands, it helps me reflect on ideas and possibilities that I just don't have access to any other way. So if this works for you, totally cool. If not, that's fine too. This is a part of my design process, just like sketching is, and just like making computer models is. It's just a way to unlock a different part of creativity. So in part 2 of our model making series, we're going to be looking at a collection of tips and techniques, things I've developed over years in making models. Part 1, if you haven't caught that, you want to watch that first. That's kind of the overview. This one really gets into the details. Making architectural models obviously involves lots of cutting. And we're talking about manual cutting methods today. We have some tools to discuss first. The tools you choose will be dependent on the types of materials you're working with. With wood, anything generally less than a 1/16 of an inch, and all of this is very thin stock here, with the exception of these thicker pieces. All of this I'm going to be cutting with my Olfa L2. This is a utility blade, and I like the black blades the best because they're sharper, they stay sharper longer. And what happens is when your blade gets dull, you simply snap off the end and you have a fresh, very sharp blade to work with. Now with wood in particular, need to pay attention to a couple of things. So this piece has a grain that runs in this direction, and we can cut it in one of two ways. We can either cut across the grain or we can cut with the grain. When you're cutting with the grain, you need to be careful that your knife doesn't wander with any grain inconsistencies. So as I'm cutting the planks, and you can see there's 2 planks that make up this walkway, so I'm just gonna cut them here. I've measured out the ends, and I'm gonna take a light score here, and a second pass, and I have a nice sharp blade, and that's the key with all of this. And in my third pass, I'm almost all the way through. Fourth pass, it pops right off. Now let's take a moment to talk about this ruler. This is a cork-backed ruler here. It's a metal edge. The metal edge is so that the blade does not dig into the side of it. If this were to be plastic or some other material, the blade has the possibility of cutting the ruler if you're using a nice sharp blade. Even pressure with your hand along the length of the blade here, and really light cuts to begin with. So you're going to make a light cut and just keep making multiple passes until you get through the material here. So one of the keys with architectural model making is to keep your cuts nice and clean. That's with the grain. When you're going across the grain, I like to use something like this little square here. It's the same thing. Across the grain is a lot more forgiving in terms of how your knife is going to wander, but it also is probably going to take more passes. And just keep working at it until you get all the way through the material. Now for these thicker pieces, so we have these little cabinetry inserts here that go inside the model. These thicker pieces, this is about 1/4 of an inch thick. This you're not going to be able to cut with a utility knife very easily. So for this kind of thing, you're going to be either using a bandsaw or you're going to be using a razor saw, a fine-tooth razor saw, and you'll be using a miter box like this, and you can cut it using different angles here. That again will give you a nice clean cut. If you have a sanding block, then you can clean up the edges there. So anything generally thicker than a 1/16 of an inch, I'm probably going to be using another tool here. So some of the other materials that you might be using, corrugated cardboard or a chipboard. In general, I like this utility knife for that as well. Other common materials that you're going to be using to cut would be the X-Acto blade, and this is the number 11 blade. The thing I don't like about this is it tends to cramp your hand over time, so if you're using this for a long time, you'll get a lot of hand strain here. Quick tip is to get a foam block and use that to store your blades and your pins and things like that. So I don't love the X-Acto for that. I'll use the utility blade for cutting chipboard. And it's the same methodology. You're going to use multiple passes. Don't try and bite through the entire thing all at once. If you want to cut windows and doors, you can get something like this chisel blade here. And the chisel blade can be used to get your corners very precise. Personally, I don't use this because I find this a little too time consuming. So I'll come in with a short cork-backed ruler. I'll lay out my window on the face here, and I'll overcut the corners it's the corners in all of these that are the tricky bits. If you overcut the corners, and you'll see it looks like slightly messy, but you get nice clean cuts. Come back into the corner, make sure you get that cut nice and clean. But you'll see we have some overlap in the corners, and for me, that's totally fine. Architects make different types of models. So this is a study model that we're working with here. And a study model is just that. It's designed to help you study forms and iterate on top of, come up with new ideas. It's not meant to be a presentation model. Okay, I'll show you a trick for cleaning up this window opening. I basically have cut a little strip of chipboard, and ideally that chipboard would match this chipboard. I'm just gonna mark each side of the opening here. This is going to act almost like a little jam liner. And I'm lightly scoring each one of these pencil marks here. And then I'm going to fold at each one of the scores. A little bit of trimming to do. Trimming is often done well with these nice heavy-duty metal scissors. Okay, can you see how I fit that in that jam opening here? Now you can come along here with some white glue at the perimeter and glue that in there. But what this does is, and you can experiment with the depth that you use, but it changes the shadow and how crisp that opening appears. So I like that trick for making window openings. And one of the things about model making is once you start simulating like actual real world material wall thicknesses, the realism of your model just increases greatly. It also helps these corners, which seem a little bit messy right now, you're more forgiving of that. Let's take a moment and talk about some other cutting tools that you can use. Let's say we want to assemble this structural bay and we want every one of these bents to be exactly the same. So how do you do that? The easiest way is to make a jig. A jig is basically a template that you're going to create using any of your scrap materials. So we're going to scale out how long we want each one of our columns to be, and we're essentially going to make a little template where we can insert our column here and use this as a cutting guide. Okay, so I've basically taken a scrap piece of chipboard, and all I'm going to do is tape it to my work surface so it doesn't move. Now, I know every column that comes along here is going to be that wide, assuming I cut it at this joint. And then you just go ahead and cut as many as you need, okay? So we know we have the height there. You do the same with the width, okay? Now to assemble the pieces, we can make a jig the same way. So we have a corner here. We know if that's 90 degrees that we can put our beam in here. And really just try and keep these as simple as possible. They don't need to be elaborate. It just needs to be wide enough to move the pieces in and out. So now I'm ready to glue this other side. So I'm just going to put that over here. If I were to design this so that the jig were exactly the width of this piece, it would be just more difficult to get in and out of. So that's how you create a repetitive piece. You make all the pieces the same length and width that you're wanting, and then you make a jig to assemble it. So you've probably seen a lot of different ways people make models, compose models, and one of the ways is to design something in the computer, print it out, and then cut and build the model from there. I don't prefer this method. I prefer to build it up using a series of planes, as we talked about in the first video. Now, if I have an idea for an elevation, what I'll typically do, and let's just say we're using chipboard here for example's sake. On the chipboard, I've basically constructed the layout lines for my elevation. And here I just have a basic grid, but you can set up your window layouts however you prefer. Now, the reason I don't use a printed out CAD layout and then spray fix it to the model face here is because I want it to be more loose. I want to be able to play around with different ideas and things. So what I'll do is I'll scribe out these, let's say it's a window layout on here, and I'll come back in and I'll start cutting my window openings. I'm going to try and start putting some of these techniques together. So we talked about how to cut our window openings, sharp into the corners here. Make sure those cuts are clean. So here I have some idea of what kind of window layout I'm going for, and I'm just kind of marking it out. Okay, so we pull out these window openings, right? I've actually decided I'm going to cut it off here like this. So we have that. Let's do another one up here. Now, I prefer not to have a sort of preconceived elevation idea. I have some idea, but maybe I want to experiment with this. And so that's the reason for drawing layout lines on the chipboard. The other thing that's nice that this does is it starts to give some added depth and dimension to the face here. So I really actually like how this feels when you have some line work here. An additional technique that we can layer onto this is to start scoring. So scoring you'll use for a lot of different things. On elevation models in particular, it's kind of a nice thing, and I'll show you what I mean here. So I've basically lightly gone and made the first cut, and we've been always talking about making light cuts, forceful cuts, but a number of passes. Now I've cut through the top layer of this chipboard, and then what I'm going to do is I'm just going to peel back the top layer here. And this technique can be used to indicate different materials. It can be used to indicate just joints if you just use a scoring mark and then you paint it. Changes in texture. Oftentimes I'll use this on like a ground plane to indicate a paving surface or something like that. And you can see we can do this wherever we choose. Make a light score. Grab the paper face and pull it back. Clearly haven't scored this enough. Now, if you'd like, you can come back and sand this out, and you can really work on it to get it nice and clean and crisp, depending on what kind of texture you want on the face. So that's one scoring technique. Another use for scoring will help you save some time. Here you can see in this model, I've glued all of these corners, which meant I cut these planes first and then I glued them at each one of the corners. One way to save time doing that is by scoring a sheet of material. So here I have cut a strip of material. It's the right width, and then I'm going to come in and I'm going to score here. That's just a light cut, probably cutting 2/3 of the way through. This is a really thin material, so it doesn't take much. And you'll see we can just fold this corner, and this one. And instead of having to glue in 4 places, we only have to glue in 1 place. So I just need to touch a little glue there, and that gets us our box. And this works for all sorts of shapes. The other thing I like using this for when I'm building study models is I'll score these little L shapes or U shapes. And they're these kind of space-defining gestures. So think like Barcelona Pavilion, right? Planes and walls and columns. They're really useful. The score technique allows you to quickly bend small pieces and use them as sort of roof forms to test out roof ideas. I really like these L-shaped forms as space-defining elements, especially early on when you're just coming up with conceptual models. Okay, another use of the score. The quintessential gable roof, right? Score down the middle of the material. Here we have an uber long house, right? If you're using something like a corrugated cardboard, really like this scoring technique as well. Make sure you make it through the whole face, but you can start really playing around with this. Adds some visual interest and also gets you thinking about, you know, the ground plane manipulation, material differences, textural differences, because, you know, the reality of building architecture is it requires a lot of materials, and it requires interacting with the ground plane, and it requires thinking about textures. And, you know, a model that's one-dimensional like this, where there's just a, you know, a planar face here, is deceiving, because, you know, this is actually composed of individual boards or metal siding, a whole range of things. So start playing around with textures. It's kind of an interesting way to add some diversity and variety to your model. Okay, let's talk for a moment about the types of glue you can use. There's Elmer's glue, and I keep this in this really small container, and I keep it sitting on the desk on its side so that when I need to pick it up, it's very close to the tip. That's the only reason for that. White glue, Elmer's glue, things like Sobo, they're great because you have time to reposition your pieces, and we're going to talk a little bit about how I'm going to use it here with this model. But it's how I sort of created these little slats I wanted to be able to reposition. If you use something like hot glue, it's great because it sets really fast, but it doesn't give you a lot of working time with it. So when you're using small detailed pieces that aren't very forgiving, I defer to something like a white glue, like Elmer's. When you're using something that just needs to be, you know, done quickly, like this walkway plank here, you can see I've just glued the underside of these little planks and just set it in place very quickly. It doesn't show, so it's not exposed really, which is great because hot glue is kind of messy, it's globby, and I'll show you some tricks for how to use it more effectively. But the third option here is to use something like a CA glue, a super glue, and I don't use that very often. It's very unforgiving. You can stick your fingers together. Any materials that it touches, basically they're glued to sort of permanently. Hot glue, at least you can remove and replace pieces, and that's the value of this for study models. If we just look at this little sort of facade piece that I'm layering up here, now I have some wood details that I want to add on the face here, so I'm going to use white glue for this. White glue, very forgiving, dries clear. I prefer the Elmer's to the Sobo. The Sobo tends to me to look glossy when it dries, so I don't like that look. So I just use Elmer's. I've always used Elmer's. Just use whatever you prefer. So you can see I have working time here. If I were to use a hot glue, it's very unforgiving. As soon as I stuck the piece, it would be ready to adhere, which is great in some cases, and I will be using that for part of this. So I've pre-cut these pieces, they just kind of fit in place. Adding three-dimensional detail to your models like this, where you're adding depth and shadow, really helps your model to pop, helps you to think about how it's actually constructed. Now, the top three pieces here, I'm going to use some hot glue because I want this to set more quickly. I'm just going to dab it on each end. and you notice I kind of make a circle. The circle cuts off that little thread that exists on the hot glue. Okay, so I've hot glued the top sections here. I've got white glue setting on these pieces. Now I want to add some cross braces here, cross members. So I'm just going to come in and do that with some white glue because I want to be able to reposition these. So for these cross members, I'm just going to use some white glue. Remember, all this will dry clear, so you don't have to be exact. If you have some layout lines down below, like I do, that's helpful. If you have this cutting mat and you're using a grid, that's helpful. Now, if this were the hot glue would be way less forgiving than this, so it would have already dried. Okay, I want to add some cross bracing here. I'm just going to come and measure some wire. For this one, I'm going to glue one of the ends. And then I'm going to come to the other end. I'm going to glue that end. Trying to use as little as I can. This would be a good application for CA glue. One end and then glue the other end. And then what you can do is kind of come back and clean up those joints if you need to. If they're just too messy, kind of hit it with the edge of your finger to pull off the excess glue. And then with the hot tip, you can kind of come in and clean up the joint and hit any of these little stray spurs that are flying off of it. There's these kind of little glue hairs. Other part of our brace. You can see why having something that's quick drying here in this particular case is beneficial. Just waiting for white glue to dry in that scenario, not good. Just gonna come in there and try and clean it up with my fingers as best I can. This is just kind of messing around. This is not, you know, this isn't for a house necessarily that I'm doing, but it's just to show you how adding detail, and in particular structural detail, is particularly convincing in these little models. If you think about how wind will blow on a building and what forces that induces into, say, a facade, you start to understand why they're designed the way they are, why you see structural bracing, because when the wind blows on one face, you need to resist forces with tension or compression, and X bracing is actually a pretty efficient way to do that. So you can picture this being layered up into a facade. Maybe we have some glass over this. Maybe this is just an armature for something else. Here I've taken some thin Mylar sheet, and you can do this with a vellum sheet as well to simulate glass or glazing. I put some pencil markings on one side of it, and you know, we could even go as far as to sort of cut windows out of it. So let's cut a window out of this. the thing that you start thinking about when you start building these models is how you can layer on all these systems and details. You know, there are these real world systems that exist in a building. Heating, ventilation, air conditioning systems, floor systems, structural systems, bracing, plumbing. And you can start to see, like, you know, we can really start to layer these things up and then start to study how things might work within those subsystems. You know, another layer to this whole thing is we can start looking at taking our markers, thinking about how the glazing might be colored or shaded. Presuming this is glazing. So there's just like all these layers of subtlety that you could start playing with and adding to your models. And I think it's a really great way to start to generate other ideas. You know, now I'm starting to think, okay, well, like, do we actually, are there pieces that move in this facade? Maybe there's overlaying grids. You know, there's just lots of opportunities. This study model is an armature for experimentation, and that is really how I think you should look at it. Use the techniques of collage to start developing a structural framework, start making this architecturally real, start playing with planes for walls, planes for roofs, start defining circulation paths, start thinking about landscape elements and water elements, where light comes in, how doors and windows operate, work, how people move in and around the space, what scale the space is. It's nice to have some ambiguity to the scale of the model here. I made a ton of model making videos. Check the end screen here for the links to those, and we'll see you again next time. Cheers, my friends.